All right. Hello guys, my name is Lazaro, and today we're going to be doing a medium LeetCode problem. This problem is called sort an array. Given an array of integers, nums, sort the array in ascending order. So let's look at example 1. Our input is nums, which it's an array of 5, 2, 3, 1. Now this array sorted in ascending order, the answer is going to be 1, 2, 3, 5. Something else is, for example, this other array right here, 5, 1, 1, 2, 0, 0. The answer for this is going to be 0, 0, 1, 1, 2, 5. So this second example tells us that there could be repeating numbers. And by looking at the constraints, we also know that there could be negative numbers as well. All right, so now let's dive right into this problem. Now, this problem could be solved in one line, because most programming languages, they have a built-in function to sort an array. But that's not what we're going to be doing for this video. For this video, we're actually going to be talking about a sorting algorithm. And the algorithm we're going to be talking about is called merge sort. All right, there should actually be some space between this. So now, why are we going to be doing merge sort? The reason we're going to be doing merge sort is because its time complexity is n log n. Now that's a pretty impressive time complexity for a sorting algorithm. So this is the one we're going to be going with. Now something I want to point out is another benefit of actually writing out the code for merge sort instead of using the built-in function is that during an interview for a company, they might not accept that built-in function. They might tell you to use an actual sorting algorithm. Also, something else I do want to point out is that there's various sorting algorithms. There's quick sort, there's bubble sort, there's multiple. But for this video, we are going to be focusing on merge sort because merge sort is generally good. Okay, cool. So now let's actually get into merge sort and how it operates. So given this array, this 5, 2, 3, 1 array, how can we sort it using the merge sort algorithm? Let me write up here using merge sort. There we go. So what merge sort does is it breaks the array in halves and then tries to sort it, those two halves, try to sort each of them and then combine them. So for example, if this was our given array, using merge sort, it will break into half, it will find the middle and then break into half, and then we'll be left with 5 and 2, then 3 and 1. We'll be left with these two arrays. But this could further be broken down into a half. For example, this 5, 2 can be broken down into just 5, and then into just 2. Same thing with the 3 and 1. So now that we only have one single element in this array, we can continue. So knowing the two halves of this bigger array right here, and knowing that it's 5 and 2, we can now merge it and get the right answer. Or not merge it, we can sort it and then put it all into just one array. So this 5, 2, let me put it like this, there we go. These 5, 2, they're going to be compared, their elements are going to be compared, and then it's going to put into an array that is sorted. So obviously the 2 is less than the 5, so the 2 is going to move in first. Then since there's nothing in this array, and the 5 is still left, we just add the 5 to the array. And that's how we get the 2, 5. We also do something pretty similar on this side. We get 1 and then 3. Now once this is built out, we can do it one more time. We can now take both of these arrays and compare them. Compare their elements. So looking at this array on the left, we were on 2, and then on the right we're on 1. Which one is less or lower? The answer is 1. So now we add 1 to our answer array. Now 1 is out. Now we're going to compare 2 with 3. 2 is less than 3, so we add 2, and then 2 is out. Now we'll compare 5 and 3. 3 is less than 5, so 3 is the answer. And then finally, we're only left with 5, so we add that. And this is how we get a sorted array. Now something you might realize here is that there's duplicate work. And that duplicate work is where we're breaking the array into halves, and then we're comparing every element in an array. This gives us a hint that we can use recursion for this problem, which once we write out the code, that's exactly what we will use. But now let's talk about another input, just so you can guys see when it's not even. So let's say our input was odd. So our input was 5, 1, 1, 2, 0, 0. This is the second example of the problem. We can break these into halves with no problem. 5, 1, 1, and then 2, 0, 0. But now we need to break it one more time, and there's an issue. The issue is that we're going to be left with 5, and then over here, we're going to be left with 1, and then 1. Same thing is going to happen over here. We'll be left with 2, then we'll be left with 0, and then 0. Now, a question you guys might be asking yourself right now is, why is it 5 and then 1, 1? Why is it not 5, 1, and then just 1? Why is it not this case? Well, the reason it's that is because, remember, merge sort takes the middle and then cuts the array at that position. The length of this array is 3. 3 divided by 2 is going to equal 1.5. But obviously, we don't have a 1.5 index. So we floor this to just 1. And then, since we know this is where our middle is, we're going to say that everything to the left of 1 is going to be put into an array. And then everything at 1 and then after 1 is going to be put into another array. This is why we get the 5 and then the 1, 1. Cool. So now we're at this situation where, well, here, since this array is can still be halved, it goes ahead and does that. Now, since it has these two separate, it sorts them, and then we get 1, 1. Then this 5 comes down here, and we get this. Now let me go ahead and do this on this side as well. The 2 is going to drop. Then we're going to have the 0, 0. And then we're going to sort them, which is just still going to be 0, 0. Now we're at this place. Here, now the 5 actually gets some action and is going to be merged and then sorted with this other 1, 1 array. So we'll be looking at 5 and we're going to be looking at 1. 1 is less than 5, so we're going to put 1. Now we're going to compare 1 with 5 again, and 1 is still less than 5. And now since we have no other element in the other array, and this is only the 5 remaining, we add it. We also do something pretty similar over here. Actually, it's the exact same thing. Remember, this is recursive. We're going to compare 2 with 0. 0 is less than 2. So that 0 is out. And now we're still going to compare 0 with a 2. 0 is less than 2, so we add that. And now the only remaining element is this 2. Now we add that 2 to the array. And we're left with that. We're left with 0, 0, 2. Now we're going to take these two separate arrays and also merge and sort them. We're looking at 1 and at 0. 0 is less than 1. We add the 0. We're still looking at 0. If 0 is less than 1, we add the 0. Now we're looking at 1 and 2. 1 is less than 2. We're looking at 1 and 2 again. 1 is still less than 2. We're looking at 5 and 2. 2 is less than 5. And now we're only left with 5, so we just go ahead and add it, and we get our sorted array. And this is the exact logic or the steps that a merge sort algorithm uses. Let me go ahead and separate this out. Might be a little bit confusing. Awesome. Then let me center this. So this is exactly how we're going to write a program. We're going to write a program that's going to take the middle of our input array and then cut it at that middle index. And then it's going to continue doing this and doing this until its array only has a size of 1. Then when it does have a size of 1 on its left and right, then we're going to merge and then sort those two arrays, which is this area right here, where after it's just a size of 1, we can start actually merging them. All right, so cool. Now that we looked at the logic and how a merge sort algorithm works, let's actually write out the code for this problem. All right, so let's get into it. So since we know we're going to be doing this recursively, we're going to want a couple of functions. Now, the problem starts off by giving us a function called sort array. So let's go ahead and just make that our function name. Sort array. And this is going to take nums. Awesome. So now within this function, we want to start off with a couple of things. We need to remember that when the array only has one element, we need to just return that array, because we can no longer break it up. So in the beginning, that's what we want to add. We want to check that if the length of nums, I should really add an S here. There we go. So we want to check if the length of nums, if this is equal to 1 exactly, then let's just return nums. We know we can no longer break it up. Else, if nums is greater than 1, then we know that we could break it up. So we need to find that middle point. So mid is going to equal to the length of nums and then divided by 2. Now this is pseudocode, but it might also resemble Python because that's the language I program in. So that's why I have 2 slashes. That 2 slashes basically does integer division, and if there's any decimal point, it floors it. Awesome. So now that we know we have a middle point, this is where we get into the recursive section. We want to get the left array of this bigger array, and we get that by calling sort array. And what we pass is nums, but index from 0 all the way to the middle is. And this is to give us that left subarray. Now we also want the right subarray. So we do the exact same thing, but instead of starting from 0, we now start at middle. And we go all the way to the bottom, which is basically the length of the nums. There we go. So now that we have our left and right, we can now perform the merging and the sorting. And that's going to be a separate function. So what we want to do is just return that other function, calling that other function, let's call it merge sort. And then let's pass it the left and right. Awesome. Now remember that we're going to be doing this recursively. So this return is going to go all the way, is going to break the array all the way down to just one element, and then it's going to merge it and sort it. And at the end of this recursive of these recursive branches, it's just going to return one big sorted array, which is going to be our input nums was sorted. Now let's create that other function, that merge sort function. So let's start it with function, and let's put merge sort. And then we'll get two arrays, left and right. Now here we want to create an empty array or an empty list. And this is where we're going to put all of our elements from left and right, but in sorted order. Something we also want to do is create a two pointers called P1, set it equal to 0, and then P2, set that equal to 0 as well. These are both going to look at the first element inside of left and right. And then later on, we'll do the comparison. We're going to be doing this comparison inside of a while loop. So while the P1 pointer is less than the length of left, and the P2 pointer is less than the length of right, then we want to do is, now we want to take those two elements at P1 and at P2, and then see which one is less than. So for example, if the element that's at left at position P1, if that's less than or equal to the element that's in the right array at index P2, then what we want to do is add to our merge list. So we want to do merge dot append. We want to append is left P1. But since we just added that element at P1 in the left array, in the left list, then we also want to increment that P1 pointer. So now next time when we run through this while loop, the next iteration of that, we're looking at a different element, at the element that's one greater than of the current P1 index. So if this is not the case, then that means that the element that was in the right array at position P2 is less than the element that's in the left array at position P1. So what we want to do is now, instead of appending the element that's on the left, we want to append the element that's on the right and add position P2. Then we want to also increment this pointer by 1. So now that's all we need for this while loop. Once this while loop is done, we should have all the elements inside of the merge list. But it might be the case that the left list its length is less than the right list. So in those cases, that's where we want to add this if loop, this if block. right after the while loop. So if P1 is less than the length of the left array, then we know that P1 did not go all the way through the left array, or the left list. Sorry, I keep on using them interchangeably. But if this is the case, then what we want to do is we want to add all the remaining elements that's on the left list. So we want to extend our list and add all the elements that are on the left, starting at P1 and going all the way to the bottom. Else, if P2 is less than the length of the right array, of the right list, then we also want to do the exact same thing. We want to extend the merge list, but instead of looking at the left array, we want to of the left list, we want to look at the right list and go all the way to the bottom. Now you might be asking yourself, well, why is there an if and an else if? Why isn't it two separate ifs? Well, the reason for that is because with this while block, one of them is destined to reach or to equal to the length of one of the lists. So either P1 will equal to the length of the left list, or P2 will equal to the length of the right list. It's not possible that both of them are less than the length of their list. So that's why we have that if and then else if. Finally, after this, we can just return that merged list. And from this, we have all the code we need to write out a program that executes the merge sorting algorithm. Now, let's see if this actually works. So let's actually put it here on the left, and I put this on the right, and let's see if it works. So like we talked about, if the length of nums is equal to 1, then we just want to return nums. Else, we want to find that midpoint and set that equal to nums divided by 2. And I'm doing / because since I'm using Python, I want to floor it. Else, let's carry on. After we got the mid, let's carry on. And now let's get our left subarray, which is going to be equal to just calling this function recursively and passing it the elements from 0 to mid. As you can see, I didn't write the 0 because Python would interpret that and know that since I didn't pass a value here, it would automatically start at 0. Then the right is going to be equal to pretty much the exact same thing. But instead of starting from 0 and ending at mid, it's going to start from mid and end all the way to the length of nums. I'm also not writing length of nums like I did here because Python would also interpret that. Since I didn't write a value here, it would know to go all the way to the end until it can no longer continue. So other than this, we can just return self.merge, then pass it the left and right, and now we can actually write that merge function or method. So let's call it merge, pass it self because we are in a class, and then let's pass it left and right. Now let's create that. Here I'm already D. I didn't write a D here, but it's fine. Let's create that empty list. Then let's create the pointers. And now let's create our while loop. So while the P1 pointer is less than the length of left, and the P2 pointer is less than the length of right, we want to do some logic. If the value at the left at position P1 is less than or equal to the value on the right list at position P2, then what we want to do is add that left value. And also let's increment our P1 pointer by 1. Else, we want to do pretty much the exact same thing, but instead of the left, we want to do the right. And instead of increment P1, we want to increment P2. Now, if our P1 pointer didn't reach the length of the left list, then we know there's still some numbers on the left list that we should just automatically push to merged. So we want to do merge.extend left starting at position P1 and all the way to the end. Else, if P2 is less than the length of left, less than the length of right, then we do the exact same thing, but instead of extending left, we're going to be extending from right, starting at position P2 and going all the way to the end. Then we can just return merge. Now here I have a couple of test cases. Let's run this code, see if this actually works or if I made a typo. All right, I did make a typo. Oh, it's if, there we go. Let's run it one more time. All right, and it gave us a wrong answer. Let me see where that is at. Okay, here it is. Instead of doing P1 at the right, we want to do P2 of the right. It was my fault for just copying and pasting. Now it gets accepted. Now let's submit. And we do get the right answer. Awesome. So hopefully you guys enjoyed the video. If you did, then I highly encourage you to join our Discord server that's linked down in the description. We send out problems like these for both beginners and advanced programmers every single day, just to make sure they're always on top of it and they're prepared for any interview question. Other than that, hopefully you guys enjoyed and have an amazing day. Thank you for watching.